Hello everyone, welcome to Chemistry Art. So today we are going to discuss about the experiment in which our aim is to determine the concentration or molarity, we can say, of KMnO4 solution by titrating it against the standard solution of M by 20 Mohr salt. And the Mohr salt it's a ferrous ammonium sulfate. Okay, so in this experiment we have to find out the molarity of the given KMnO4 solution. Okay, and with the help of this molarity we can find out what is the strength of KMnO4 solution. So you must know what is the strength. Strength is actually how much amount of solute is dissolved in particular amount, means particular volume of the solution. It is called strength. So we'll check out it later, but first of all, what is the procedure? Okay, so I will show you whole video, and in this video first of all I will explain the theoretically, and then after I will show you how to exactly prepare the solution of Mohr salt. And the molarity of Mohr salt solution we have to take is M by 20. So how to prepare M by 20 solution, because in examinations students need to prepare this solution, and so many students don't know how to prepare, even they don't know how to calculate the particular amount of the solute, means how much solute they have to take and dissolve to prepare particular molarity solution. Means they don't know that in how much volume of water they need to dissolve what amount of solute. So it is very important in chemistry that if you are given a particular molarity, you must know that how to prepare a solution of that molarity. So here first of all I will show you how to prepare the M by 20 solution of Mohr salt. So it's all about the preparation of M by 20 Mohr salt. Okay, so here you can see that I have drawn here a weighing balance. Then this is a beaker. This is a SMF, standard measuring flask. We need to use this only to prepare standard solution. Thereafter, this is a pipette, and it's a conical flask we will use during the titration. Okay, so actually this experiment is the titration between the KMnO4 and Mohr salt, but for that the KMnO4 will be given us, means its molarity is unknown. We need to find out its molarity, it's our aim, but for that we have to prepare M by 20 solution of Mohr salt. And let me tell you how to prepare the M by 20 Mohr salt solution. But for that you need to know about the calculation, means the formula of molarity. What is molarity? If you know, the molarity is the moles of solute dissolved in a 1 liter solution. So that is the molarity, and from that formula we can write down, instead of mole we can write given mass upon molar mass. Means I can write to find out what mass of the Mohr salt exactly we need to weigh in preparation of M by 20 solution of Mohr salt. Okay, so first of all calculation is mass of solute, okay, into 1000 divided by molar mass of solute, means molar mass of the Mohr salt, and what volume we want to prepare, volume in ml, because we have multiplied here by 1000. If you want to take volume in liter, you do not need to multiply here with 1000, you can write volume in ml, because actual formula of the molarity is moles of the solute divided by volume of solution in liter. Okay, but we need to calculate here mass, and what mass we required to prepare M by 20 Mohr salt solution. Now what is M by 20? Here this is the formula of molarity, calculation of molarity. Okay, it is it's equal to, let me write here, capital M. Okay, so capital M is 1 by 20. We need to prepare 1 by 20 solution because it's given here in aim. Then after mass means I can write here W for that into 1000 divided by molar mass of the solute. So this is the formula FeSO4 NH4 twice SO4 to 6H2O. This is the formula, chemical formula of Mohr salt, and its molar mass is 392. So here divide by 392 into volume of solution. Now see here what volume you are going to prepare. If you want to prepare 100 ml solution, then you need to take here 100 ml. If you want to prepare 250 ml solution, so you will write here 250 ml, and generally in schools they are providing the flask, the standard measuring flask of 250 ml. Okay, so 250 ml we will take here. If you have 100 ml flask, then you will take 100 ml instead of 250, and then after calculate what mass of the Mohr salt required to prepare m by 20 solution. So we will make subject to W over here, and it will give you the mass, what mass we required. Means if you are making subject to W, so 1 by 20 into, you can write 392 into 250 divide by 1000, and here we will get 4.9 gram of Mohr salt to prepare m by 20 solution of Mohr salt. So here you can see that this is a weighing balance. Okay, here I have drawn here the watch glass. You can take any of the watch glass which should be cleaned, and in weighing balance you need to weigh out with the help of spatula 4.9 gram of the Mohr salt. So be carefully, the mass whatever we are going to take is very important, not more than 4.9, not less than it. You have to be accurate in this mass. Okay, then after what you will do is, see, this is a standard measuring flask. In this flask only we are going to prepare the Mohr salt solution, and for that it is not easy to transfer this salt into this flask. That is why we will take the help of a beaker. Here you can see that this is a beaker of 50 ml. So what I will do is I will transfer this Mohr salt into the 50 ml beaker. Okay, and then after we will add minimum quantity of water in which it can be dissolved. Remember, we are going to prepare 250 ml solution, so this quantity of water should not be increased more than it. So I am already taking here 50 ml beaker, and it will be dissolved into the 50 ml solution. 4.9 gram we are taking, so it is easily dissolved in it. Okay, we have to make slightly acidic the solution. What I am doing is, generally I am just adding some drops of the H2SO4, dilute H2SO4, okay, into the Mohr salt, and then after I will dissolve it. So we can prevent the hydrolysis of that Mohr salt. So keep this thing in your mind. Okay, and then after we'll add the water. Now just dissolve the Mohr salt into the water, and then this Mohr salt will transfer in this standard measuring flask. Okay, now we need to fill the standard measuring flask with the help of water. So suppose this is a water, distilled water you have to take always by preparing the solution. Okay, so the 250 ml scale, you will find here one scale. Okay, so exactly you have to take 250 ml water. The scale should be maintained, means you have to add water up to this scale only, not more than it. Okay, once you are reaching here, then after add water very slowly. You can also use dropper, just remove the funnel and then after add with the help of the dropper. Okay, so now here this is a solution of m by 50 Mohr salt, and this solution we will use to titrate the KMnO4 solution. And for that what you need to do is, this is a pipette. Okay, with the help of this pipette we have to take 10 ml solution. From this pipette we need to add the 10 ml solution of Mohr salt into this conical flask, and then after we will perform the titration of Mohr salt and KMnO4. But for that, as you know that we need to calculate the Mohr salt, what Mohr salt we will require, and in how much mass, in how much volume we will dissolve it. So we are going to dissolve 4.9 to prepare 250 ml solution. So let's prepare it.
Okay, so here it is watch glass, and in it we have taken the Mohr salt. We have to take 4.9, so it's 4.5, 6, 7, 8, 9, 5. It became 5, so we have to take out 0.1 gram. So with very carefully take out 1 gram, and it's now 4.9. 5, no, yes, 9. Now it is final 4.9. So we are going to dissolve this 4.9 gram in 250 ml water. Okay. Okay, so I have taken this all the component in beaker, and I will dissolve in a minimum quantity of water. But remember, you have to make it slightly acidic with the help of H2SO4. So there will be hydration cannot take place of the Mohr salt. Okay. Now this solution I am going to add in the standard measuring flask. Here you can see the measurement. So this is the solution dissolved in minimum quantity of water, distilled water we have to take, and now make this solution 250 ml. Okay, here the marking scale is there of 250 ml. Till that scale you have to fill the water. Okay, so very slowly you have to use a dropper, so the solution will not go up to the scale. Okay, so here we are going to add very carefully one drop of water with the help of dropper, so our solution will be not more than 250 ml. Okay, so now here finally we have prepared 250 ml water. Only one drop is remained, so I am going to add it, and yes, now it's 250 ml Mohr salt solution. Okay.
As you have seen that we have prepared. Okay, so you have seen that we have prepared m/20 solution of Mohr salt. Now further procedure is to fill the burette with the KMnO4 solution. Here you can see that this is a burette. Okay, in this burette you have to fill KMnO4 solution, and burette should be filled completely. Okay, after the cork, the no air bubble should remain. If it is remain, just open the cork, close it, open it, close it, and let the KMnO4 solution flow. The air bubble will be removed automatically. Okay, then fill it again, just make it 0. Okay, your KMnO4 solution we need to take 0. You can take pipette, you can take burette of 25 ml or 50 ml. Okay, I will prefer 50 ml burette. Okay, and we already have taken in conical flask 10 ml Mohr salt. I told you in 10 ml of Mohr salt we have to take in conical flask. So in this conical flask we have 10 ml Mohr salt. It's Mohr salt, and we need to add 20 ml of H2SO4. Okay, now we will start addition dropwise. Okay, dropwise addition of KMnO4 till the color change colorless to light pink color. At the very light pink color you need to stop addition, and that is our end point. Okay, so first of all we will take pilot reading, which we will from which we can say that our reading will come closer to that reading. Okay, so let's start it and let's check out whatever our pilot reading is coming. So whatever pilot reading is come, initial reading we have taken 0, and let's find out what reading we are getting.
Okay, so it's a burette filled with KMnO4 solution. There should be no air bubble after the cork, and here you can see the marking 0. Okay, you have to watch out the upper meniscus. Now in the conical flask we will take 10 ml Mohr salt solution with the help of the pipette. Okay, so pipette, 10 ml pipette we have to take, and add 10 ml Mohr salt into conical flask plus H2SO4 around 20 ml. Okay, approximately 1 test tube you can add. So 20 ml H2SO4 we will add to prevent Mohr salt from the hydrolysis. Okay, and then after we'll start titration. Okay, so let me take the 10 ml Mohr salt from the prepared Mohr salt solution, and here it is 10 ml Mohr salt solution. I am going to add this into the conical flask. So like this you can add, and you have to carefully add it. No any single drop should be remain into the pipette. After that I will add H2SO4. We can take approximately 20 ml. For that you can use 1 test tube. Okay, or you can also use 10 ml jar. I am using 10 ml jar for exact volume. So here 20 ml H2SO4 is gone into the conical flask, and now see here background should be white, so you will observe the color very carefully, and here the color change should be colorless to the light pink color. So, and K-4 is the self indicator. Here you can see that when I am adding the drop, the color is becoming pink, but it is disappearing yellow. So very light pink color should be remain stable, so that will be our end point. Okay, and here let's check out whether the color is stable or not. So still it is going, so it means I have to add more K-4 with continuous stir. Okay, so like this we will add K-4 solution into the Mohr salt and H2SO4. So let's check out when the color is coming. Yes, here you can see the light pink color is appeared and it is stable, it is not disappearing. So now it will give a final reading. Our final reading came 9.9 ml, and we have to take another 3 readings, and we'll take concurrent reading from it.
Okay, so as you have seen that 9.9 ml we got the reading of K-4 which is used. So initial reading, here you can see that in the observation table we are filling the data. Okay, so it's a serial number. First reading is pilot reading, volume of K-4 in burette. Initial reading was 0.0 ml, final reading is 9.9 ml. Now for further 3 readings you can continue from the 9.9 also, and you can again fill the K-4 till 0 ml. I will prefer to fill it till 0 ml. If your burette is 25 ml, then you have to fill once. Okay, so I prefer that you will fill the burette with the help of K-4 every time, so you do not need to worry after 2 readings or 3 readings. Okay, so every time we will take initial reading 0.0 ml, and minimum 3 readings we have to take, rest of the pilot reading. So total 4 readings will be there. And here the volume of K-4, we have already taken pilot reading 9.9, so volume of K-4 is 9.9 ml. And then we have to choose the concordant reading. Concordant reading means whatever 2 or 3 readings we are getting the same reading or closer reading, that we will take as a final volume, use the K-4 solution. Okay, so that will be the concordant reading. So let's check it again, and I will write directly. You know, I have already shown you the how to take the reading, how to take the reading of K-4 use. Okay, now we will just do calculation. So let me perform another 3 readings, and then after I will show you how to calculate the molarity of the K-4 solution, and from the molarity we will calculate the strength of K-4 solution. Okay, so as you can see here, these are the data I got. I performed after the pilot reading 3 particular reading I have taken, and 10.0, 10.1, 10.0 I got these 3 volumes of KMnO4. Now difference is 10.0, 10.1, 10.0, and as you know that we need to take the concordant reading, and that is the whatever same reading we got, we have to take it. So here 10.0 is the same, so I am going to take the 10.0 as a concordant reading, which we will take in a calculation. Okay, for calculation we need to understand about a chemical equation. This is a chemical equation, what reaction is going on. Okay, so actually first of all, when KMnO4 and H2SO4 reacts, it forms K2SO4, MnSO4 and 3H2O plus oxygen, and that oxygen is oxidized to the Mohr salt, actually FeSO4, NH4 twice, SO4 into 6H2O plus H2SO4, and converts into the Fe2SO4 thrice 2 NH4 twice SO4 plus 13H2O while oxidized with oxygen. So this is the final equation, final chemical equation. 2 moles of KMnO4, you can see here 2 moles of KMnO4 with H2SO4 Mohr salt converts into K2SO4 potassium sulfate, MnSO4, FeSO4 thrice, H2O, NH4 twice, SO4. And ionic equation, reduction half reaction and oxidation half reaction. This is the oxidation half reaction, MnO4 plus 5 Fe2 plus 8H plus. This is a full reaction, we can say Mn plus 2 plus Fe3 plus H2O. So here you can see that Fe2 plus converts into Fe3 plus and Mn is converting into Mn2 plus. So Mn's oxidation number will be plus 7 here, if you can calculate. So here main thing is, for calculating the molarity we need to use this formula, and the formula is A1 M1 V1 is equal to A2 M2 V2, where what is M1 V1? So M1 V1 we are considering as a molarity and volume of the KMnO4, and M2 V2 we are considering the molarity and volume of the Mohr salt. And what are the A1 and A2? So A1 and A2 are the electrons required during the ionic equation if we are writing. Okay, so during the ionic equation, whatever number of electrons are required, for example A1 means here A1 will be 1 and A2 will be 5, because we need to balance it. Here manganese is having oxidation number plus 7 and converting into the plus 1. Okay, so here the already number of electrons we can say it's a 5. Okay, and Fe is converting into the Fe2 plus, so we need to balance it. Here difference is of 5 and here difference Fe2 plus to Fe3 plus is of 1, so we have multiplied here with the 5. Okay, so the A1 will be 1 and A2 will be 5, but here as you can see that 2 KMnO4 is used, so we will take 2 by 10 instead of 1 by 5. Okay, we will take 2 by 10, and what our aim is to find out the molarity of the KMnO4. Okay, so we will make subject the molarity to KMnO4. Here volume of KMnO4 used, that is our concordant reading, whatever volume is used, so it will be 10.0 ml. Okay, then M1 V1, M1 is the molarity of Mohr salt. It is, we have prepared it, so the molarity is 1 by 20, and volume, what volume we are taking? So if you remember 10 ml Mohr salt we have taken, so we'll take 10.0 ml. Now we just need to find out the molarity of KMnO4, so I can write this equation as 2 into 2 by 10 into this 20 will move upside. Okay, this 10 ml we need to multiply over here. Okay, this 10 ml it will move to divide, then this 20 up, so right like this. Okay, and the molarity we are getting is how much? Can you calculate it? Just calculate what molarity you are getting. So molarity we are getting is 0.01 molar. of KMnO4 solution. Given K. Okay, so it's correct. We got 0.01 molar KMnO4. Now what is strength? We need to find out strength also. So the formula of strength is molarity into molecular mass. So when we multiply the molecular mass with molarity, you will get the strength of KMnO4. We are finding the strength of KMnO4 means molarity into molar mass. So molarity, we got 0.01 molar, and it is molar mass is 158. It means that the strength of given KMnO4 solution is 1.58 gram per liter. It means that in the solution which is given to us, KMnO4 solution which is given to us contains 1.5 gram KMnO4 in 1 liter solution. Okay, so this is how this experiment can done, and with the help of this experiment you can actually find out the given strength, means not given, actually the strength of the KMnO4 which is unknown molarity, and you can also find out that what is the strength and what is the molarity by the experiment. Okay, so if you like this video, please don't forget to